this problem, we will be looking at conjugated acids and bases. As a quick refresher, let's look at the Bronsted law redefinition of an acid and base. Whenever we're doing an acid-base neutralization reaction, we're going to have any generic acid interacting with a base in an equilibrium type process, whereas my acid will donate a proton, which is an hydrogen cation, turning into an anion in the process, and my base will accept that proton, obtaining that positive charge in exchange. Now, if we track each of the species, see what's happening, we can see that the acid in our reagent site has turned into a base. It is now in a position to accept a proton. We call this the acid conjugated base pair. The same is true for the base. It accepts a proton. Now it's in a position to donate that proton back. So we have a base acid conjugated pair. In our first problem, the conjugated base of nitric acid, we have the proton plus the nitrate anion forming the molecule. So the conjugated base will be the same species without that proton. So we can write it as the nitrate anion. In our second case, we have the conjugated acid of the oxide anion. So we need to add that hydrogen cation to that species. Notice that you have a -2, your hydrogen will have a +1, so you will still have a net charge. So in this case, we would end up with the hydroxide anion. If you look at the conjugated base of this other species, this becomes, let's say, the acid, so the conjugated base of that would be the sulfate anion. And lastly, the conjugated acid of our hydrogen carbonate anion would be our carbonic acid. Now, the second worked example, let me move over real quick, ask us to identify acid-base, conjugated base in each pair. This becomes relatively straightforward if we are following the Bronsted law redefinitions of acids and bases. So let's say, for instance, we have HF. If we drag it down, we have the fluoride anion. It lost a proton, therefore it went from an acid to a conjugated base. Now, if we look at the other species in this system, we have the ammonia molecule turning into the ammonium cation. It gained a proton, therefore it behaved as a base, and this would be the conjugated acid. That's pretty much what you will do whenever you're trying to identify these species. For instance, here we look at the acetate ion, acetic acid pair. This would be my base, this would be my conjugated acid. Looking at our other pair, we have water and we have hydroxide. Water actually lost a proton, so it behaved as an acid, and hydroxide is now in a position to accept it, meaning that it turns into a conjugated base.